Hello, this is Mrs. Ward, and I am going to do a video to go over the problems for the 5.1 to 5.3 review worksheet. That is the version 2, so it's the second one that we've given you. So the first problem, the first page is reviewing 5.1 and 5.2, which is simplifying and verifying identities. So the first one is simplifying. So if I have something that is a monomial, and by monomial I mean one term over one term, the only thing I can do to really simplify it is to change everything into terms of sine and cosine. So I'm going to rewrite secant as 1 over cosine, and I'm going to rewrite cosecant as 1 over sine. And then to simplify this, I'm going to keep the 1 over cosine, change the division to multiplication, and flip is 1 over sine to sine over 1. And when I do that, and multiply, I'm going to take 1 times sine, you get sine, and cosine times 1, and cosine. And then I have sine over cosine, which simplifies to tangent of theta. And that is my final simplified answer. Well, to the next one, I have something that is squared. I have the cotangent squared x plus 1. So if you recognize your Pythagorean identities, and I really hope you do at this point, you will realize that this is an identity for cosecant. So I'm going to make this cosecant squared x. And then the reciprocal of cosecant sine, so this final answer is sine squared x. So again, if you know those identities, you just make your life a whole heck of a lot easier. If not, you're going to have to change that cotangent to cosine over sine, find a common denominator, keep the 1 in place, change the division to multiplication, and flip it. So knowing those identities is key. The next one, I have cosine times the quantity of tangent squared x plus 1 is equal to secant. And hopefully you recognize this identity as secant. So I'm going to have cosine of x times secant squared x is equal to secant x. Now everything is a monomial, meaning it's not going to add to anything else. So I'm going to change everything into terms in cosine and sine. So I'm going to have this as cosine x over 1 times 1 over cosine squared x is equal to 1 over cosine x. Remember, to verify, you have to make the left side look exactly like the right side when you're done. So I could think of this, when I multiply, I get cosine x over cosine squared. And you could think of cosine squared as cosine x times cosine x is equal to 1 over cosine x. You have to do all this? No, but that's what I'm doing when I think of cosine squared, so I can see that one of them will simplify. I'm going to be left with 1 in the numerator, still have 1 cosine in the denominator, and now I have 1 over cosine x is equal to 1 over cosine x. That is perfectly fine the way it is right here, or you could have written secant x is equal to secant x. Whichever one, you just have to make sure that your final set is the left side looking exactly like the right side. Okay, the next one I have cosine cubed x plus cosine x times sine squared x is equal to cosine x. Well, I see that I have a cosine here and a cosine here, so I'm going to factor it out. And when I factor it out, it's like I'm dividing both of these terms by cosine of x. And when I do that, I will have cosine squared, my first term. Here's that plus sine. These cosines will simplify, and I'll be left with sine squared x is equal to cosine x. Hopefully you recognize this Pythagorean identity. It is the main Pythagorean identity. So I'm going to have cosine squared plus sine squared, which is equal to 1. So my final step is going to be cosine x is equal to cosine x. Okay, moving on to the next one. The next page, the back page. Oh no, never mind. I'm still on number 2. As soon as I see this pi over 2 minus x, remember you will have an identity sheet for your test. And that is a co-function identity. So I'm looking at my co-function identities. And I realize that this simplifies to tangent of x times cosecant of x is equal to secant of x. Now, once I have those monomials, in other words, nothing is squared and nothing is being added or subtracted, I'm going to rewrite everything in terms of sine and cosine. So tangent, I'm going to think of as sine of x over cosine of x. Cosecant is going to be 1 over sine of x. And secant is going to be 1 over cosine of x. Here I can see when I multiply that the sine of x will simplify, so I'm left with 1 over cosine x is equal to 1 over cosine x. So I have my left side looking like the right side. Moving on to the next one, I have cotangent squared x is equal to secant squared x minus 1. Hopefully you recognize this as a version of a valuum identity. And that secant squared x minus 1, that is going to be tangent squared x. And now I'm going to have cotangent, which I should recognize these two as reciprocals, but if you didn't, you would have cotangent as cosine squared x over sine squared x, and tangent as sine squared x over cosine squared x. And you're trying to show that's equal to 1. Here the cosines will simplify, here the sines will simplify, and then 1 is equal to 1. Okay, moving on to the back page. The back page is reviewing 5.3 where we're solving. And remember, there's two versions of solving. One is when you're in an interval from 0 to 2 pi, and the other one is when it says all real solutions. When it says 0 to 2 pi, remember that means you're going one mark around the unit circle. So once you list all those values, you're done. You're not adding any multiples of pi or 2 pi at the end. So here I have sine squared x is equal to 1. 2 sine squared x is equal to 1. So I'm going to divide both sides by 2. And I'll have sine squared x is equal to 1/2. Now I take the square root. Remember, I'm taking the square root of everything. So square root, square root, square root. So I end up with sine of x. Once I take the square root, it's going to be plus or minus. The square root of 1 is 1. The square root of 2 I cannot simplify, so I'm going to write it as the square root of 2. Now I have to rationalize, because I do not recognize that value with the radical in the denominator. And when I simplify that, I'm going to get the sine of x is equal to plus or minus the square root of 2. And the square root of 2 times the square root of 2 is just 2. I do recognize that as being my denominators of 4. So my answer is going to be pi over 4, 3 pi over 4, 5 pi over 4, that's really bad 4, and 7 pi over 4. And since it's in the interval of 0 to 2 pi, that's it. That's done. I'm not going to add anything else. Okay, on the next one, I have 3 tangent x is equal to the square root minus the square root of 3 is equal to 0. The first thing I'm going to do is add the square root of 3 to both sides. And when I do that, I end up with 3 tangent x is equal to a positive square root of 3. Divide both sides by 3. Isolate that tangent on one side by itself. So I get the tangent of x is equal to the square root of 3 over 3. Notice I did not take the square root, which means I don't have plus or minus. I just have a positive square root of 3 over 3. To remind myself, all students can tell, that's going to be in the first quadrant. In the third quadrant, that my tangent is positive. And it equals the square root of 3 over 3 with the denominator 6. So I'm going to say pi over 6 and 7 pi over 6. And again, since it has that interval from 0 to 2 pi, that's it. That's all I'm writing. I'm not going to add any multiples of 2 pi to that. All right, let's do the next one. Next one, I have find all the solutions on the interval of 0 to 2 pi. So again, I'm not going to list that multiples of 2 pi at the end. So when I do this, I'm going to, since I have two things multiplied that are equal to 0, they've already done all the hard work for me. I'm just going to set each one of those quantities equal to 0. Remember to do the 0 product property. It has to equal 0. So you have to make sure that this side is 0. If it's not equal to 0, you have to make it equal to 0. I'm asking myself, what is the sign of x equal to 0? And that happens at 2 places. That happens at 0 and pi. Then I'm going to ask myself, I'm going to add 1 to both sides. And I'm going to get sine of x is equal to a positive 1. And ask myself, when that happens, that only happens at one place, which is pi over 2. So my answer is going to be 0, pi, and pi over 2. The next one, I have 4 sine squared x minus sine squared x. Remember, in order to do anything, it has to equal 0, so I'm going to subtract sine squared x from both sides. Remember that sine to the fourth and sine squared are not like terms. I cannot combine them. So I'm going to write 4 sine to the fourth x minus sine squared x is equal to 0. I can factor out a sine squared x. I am going to do that. And remember, when you're factoring out something, it's like you're dividing every term by that. So I'm factoring out sine squared x here, factoring out sine squared x here. And to divide out from the first term, the 4 will still be there, so there's that 4. It looks like it crossed it out, and I didn't mean to do that. So that 4 is there. And then when I take sine to the fourth minus sine divided by sine squared, I'm subtracting my exponents, so that was sine squared. Here's this minus sign. And sine squared x divided by sine squared x is equal to 1. Now, I don't technically, I have sine squared x and this is equal to 0. I have two things equaling 0. They multiply, so I can set both of those factors equal to 0. So I am going to do that. Here, I'm going to take the square root, and I'm going to have sine of x is equal to plus or minus 0, which means sine of x is just equal to 0. And I'm asking myself, what is the sine of x equal to 0? And that happens at 0 and pi. Here, I'm going to add 1 to both sides. And I'm going to have 4 sine squared x is equal to positive 1. Divide both sides by 4. And I'm going to have sine squared x is equal to 1/4. Now I'm going to take the square root. Remember, I like doing square root, square root, square root. So I'm taking the square root of the numerator and denominator. So I'm going to have sine of x. I took the square root, so I'm going to write plus or minus. The square root of 1 is 1. The square root of 4 is 2. So I'm going to have plus or minus 1/2. And that happens on my unit circle with the denominator of 6. So since it's positive and minus, I'm going to write all of them. And my final answer is going to be that 0 pi, and then the ones with the denominator of 6. Moving on to the next one, I have 3 sine squared x is equal to cosine squared x. In order to solve this, I have to have the same trig function. So I can either change the sine squared into terms of cosine squared or the cosine squared in terms of sine squared. So on the answer key that's online, I rewrote this as 1 minus cosine squared. So to show you the different option, I'm going to rewrite cosine squared in this video as 1 minus sine squared x, because that's what cosine squared x is equal to. And then this is 3 sine squared x. Now in order to solve, I have to set it equal to 0, so I'm going to add sine squared x to both sides. And when I do that, I have 3 sine squared x plus sine squared x, so that's going to be 4 sine squared x is equal to 1. And I'm going to leave it like that because I just have one term. Divide both sides by 4. And I get sine squared x is equal to 1/4. And that's going to be the same work as the one that I just did. I'm going to take the square root of everything and get the sine of x is equal to plus or minus 1/2. And that's going to be all the denominators of 6. It's really that 5. It's not much better. Now, if I would have solved for cosine squared instead, I would have gotten cosine squared, cosine x is equal to the square root of 3/2, plus or minus. I'm still going to get these same answers. So it doesn't matter which way you do it, as long as you do it correctly, you'll get the same answer. Okay, the next one, I have tangent of x times sine squared x is equal to 2 tangent x. So I am going to set it equal to 0, because I don't know what else to do. So I'm going to subtract 2 tangent x from both sides. Then I'm going to have tangent of x times sine squared of x minus that 2 tangent of x, because they're not like terms, I can't combine them, is equal to 0. Here I notice that I can back out a tangent of x, so I'm going to go ahead and do that. And And when I divide this by tangent of x, tangent of x, that's what happens when I factor out, I'm going to end up with sine squared x minus 2 is equal to 0. So then I'm going to say the tangent of x times sine squared x minus 2. So I'm going to say tangent of x is equal to 0. And sine squared x minus 2 is equal to 0. Here, when is the tangent of x equal to 0? Well, remember, tangent is sine of x over cosine of x. In order for this to be 0, the sine has to be 0. It needs to be able to plus or minus 1. And that's going to have to be 0 over pi. Here, I add 2 to both sides. And sine squared x is equal to positive 2. Take the square root, take the square root. And I get the sine of x is equal to plus or minus the square root of 2. Well, I think about that for a little bit. And plus or minus the square root of 2 is approximately 1.4 something, 1.4, 1.7, something like that. I just know that it's more than 1. And remember, the sign can only fluctuate between -1 and +1. So this one, I'm not going to get any answer. So I'm going to say there's no solutions from this part. But there are solutions to the equation, and these would be the solutions. So maybe I should say not possible. Something that lets me know that you know that you can't get any solutions from this side, but you still have solutions from the other side. Alright, I hope this video helps, and we will see you next time.